In this lecture, we are going to implement the algorithm breadth-first search. Now, this implementation is going to be pretty similar to depth-first search, but instead of our algorithm going all the way to the end of the graph, we want to fan out and hit all our neighbors at that current depth. So let's see what this would look like. So we can say pub fn breadth first search. We want to pass in our graph. We want our root vertex, and we want our target vertex. And just like in depth first search, we want to pass back or return an option with a vector containing U8s. We want our visited, which is going to be a HashSet vertexes, and we want to create a new one. And we want our history, and lastly we need our Q, which is going to be a VecDeque, and we need to make our Q mutable. Alright, so we want to say we've already visited our root node, since that is where we are starting out at, and we want to push back our root node, and then we can have our while loop. So we have our current vertex again, and we are going to pop the front of our Q. Alright, so now we have our history dot push our current vertex dot value, which we did in depth first, and then if we reach the current goal, we want to return our travel history. So if current vertex is equal to our target, return some history. Otherwise, we need to check the neighboring nodes for any that we have not visited yet. So we could say for neighbor in current vertex dot neighbors of graph, if visited does not contain our neighbor, then visited dot insert neighbor and Q dot push back our neighbor. That way we're getting all of our neighbors at that current depth. And then otherwise, if we don't ever find our target, then and all nodes were already visited, then we can return none because it is not inside of our graph. So again, looks very similar to depth first search, but instead of us iterating all the way to the end, we just look at all the immediate neighbors, visit those, see if it's the value that we're looking for. If not, then we can go up one more depth. So we can now add in some of our test cases, and let's keep our test cases the same. So we'll say test fn, and we'll call it breadth first search, and we'll call it fail. And what we can do is actually come up here and we can create the same test cases that we were already doing. So we're looking for a value here that does not exist. So now we can say assert equals, and we can say breadth first search, pass in our graph, pass in our root dot into, and pass in our target or not target in this case, objective dot into, and we want to see that it returns back none. And then our other test case, we want it to actually find something, so we will say take all of this, copy it down, and say FN BFS found. Copy all this in. We will change our objective to 7, and in this instance we will say breadth first search, and we can say path here, and we can say let path equals a vec, and we expect our path to be 1, 2, 3, 4, 5, 6, and 7, because we expect 1 is going to connect to 2 and 3, so we expect 1, 2, 3 to be visited, and then we see 2 connects to 4 and 5, so then we expect 4 and 5 to be visited, and then 3 connects to 6 and 7, so then we expect 6 and 7 to be visited. So we have 1, 2, 3, 4, 5, 6, and 7. So let's run cargo tests to see how it looks, and it says we expected an enum option found our vec. Oh, we need to put some around our path. And the dreaded forgot semicolon. There we go. And we see that breadth first search fail and found both ran successfully. So it's safe to say that our breadth first search algorithm is also successfully implemented in. And again, you might have noticed that breadth first search and depth first search are extremely similar, and that is because they are. So again, the big key takeaway here is that depth first is going to go to the end of the graph, and then it will work its way back to visit any nodes that it may have missed, whereas breadth first is going to fan out, meaning it'll get every single vertex at that current depth level before moving on. So if you have any questions about depth first search or breadth first search, please feel free to ask them in the Q&A section, and we will look over one more graphing algorithm known as Dijkstra's shortest path, and we will begin talking about that in the next lecture.